All right, so we're graphing exponential decay. The form is the same as with exponential growth, but the value of the base is what changes here that makes exponential decay. And you've got to be less than 1, but you also got to be greater than 0. So the base has got to be between 0 and 1. And B is 1/4 here for this first example. You guys have a calculator handy, because I need to take like 1/4 to the negative third power, 1/4 to the negative second power, and so on. Do we have 1/4 to the negative third power? 64. To the negative second. Go ahead. Hey, just say them. Yeah. 16 to the negative first.
4.
To the 0.
1.
1. Did you have to calculate that one? We can go decimals if you want. 1/4 to the first. 0.25, right? To the second.
0.0625.
Okay. To the third.
0.0156.
Okay. To the fourth. They're getting really small, aren't they?
0.0039.
0.00. Just 2 zeros?
Yeah.
Okay, what about this one then?
That's 1 0. Right?
Just 1 0. Okay. All right. So this has just 2 zeros, so 0.0039. Okay. And the fifth power.
9.7 times 10 to the negative 4.
0.00097. I'll do that. I think that's 9.7 times 10 to the negative fourth. Okay, went scientific notation on you, huh? All right. Now, let's go ahead and graph that. I'm not getting this point on, nor am I getting, well, no, I am getting that one on. I left enough room up here for negative 2, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is right there. Negative 2, 16. Got it plotted. Negative 1, 4. 1, 2, 3, 4. Got it plotted. 0, 1 is on here. 1.25. That's a quarter of the way between here and here. I'm going to be right above that tick mark there. 2.0625. That is super close, and they even start getting closer after that, so I'm not even going to try to distinguish too much there. Now, negative 3 was way up here at 64, like way up here. So I'm going to come down from here. It drops pretty rapidly, and then it starts leveling off as x gets bigger. Okay. And I'll put an arrow here and an arrow here. Let's talk about this one, the domain. Any thoughts? Those are the values of x. All right. Good. The range. How low will this thing go? It will not cross the 0, will it? Okay, and I put a curve bracket because 0 is an electric fence, not a board fence, all right? And how high does it go? All right, so we got the domain and range of that one. Now, this is 1/4 to the x. That's this column. This is 2 times 1/4 to the x. I think I can get most of these. 2 times 64 is 128. I'm just doubling this column. 2 times 16 is 32. 2 times 4 is 8. 2 times 1 is 2. 2 times 0.25 is 0.5. 2 times 0.0625 is 0.125. All right, I may start running out of ideas here. 2 times 0.0156. Is that 0.03125? Just 0.0312? Okay. All right. Is this 0.0078? What about this last one? 2 times point. I got an idea. 0.00194, something like that. Pretty small. I'm not able to actually, when I'm graphing by hand, put that on very easily. I can't get this point on the graph. I'm not getting the 32. It's too high, but I can get -1.8 on. 1, 2, 3, 4, 5, 6, 7, 8 is right here. -1.8. 0.2, I can get that one on. 1.5, I'm doing it on. It's on here. Now I'm getting really close to the axis here. I'm going to kind of start up high because -2 would have been at 32, which is way up here. So if I'm coming down like that, let's go through these points here, and then we come down, we just say slightly above the other one. All right, for this one, domain. Sean. That is correct. And range. Caroline. It is correct. That didn't change. Even though this is double this one. Double 0 is what? What's 2 times 0? 0. So you see, doubling it doesn't change that bottom number. Okay? All right. I do want to do, this one will be this function here. I'm not going to make the table, though. I'm going to write what we should shift this second function that we did. We're going to shift it how much? We're going to shift this one how much? It's +2. So shift 2 left and down 3. Or 3 down. Okay. All right. So let's do that. Let's take the points we have and go 2 units left, 1, 2 units left, and 3 units down. 1, 2, 3 units down. That's this point right here. Also, guys, I'm going to extend this just a little bit on the bottom. So this point we shifted to here. This is the next point. We're going to shift it 2 left, 1, 2, 3 down. 1, 2, 3 down. This point, which was at 0.5, 1 and 0.5, 2 left, 1, 2, 3 down. This point is like at 0.125. So go 2 left, 1, 2, 3 down, like right around there. And even these, I'm going to kind of just draw a very faint line here. One, two, 1, 2, 3, just right above that line, so on. Okay? So I'm going to come up from here, curve down toward here. All right. Domain of this one, the shifted, the translated function that we have here. What's the domain of that one? Caroline. Okay, noticing that that's happening every time. We're not bound by what we can put in here. Now, I think the range is a little different on this one. How low does it go? What's that line here? This is 0. -3. That's that line there. It's kind of where it's serving now. How high is it going to go? When do I stop? Stop me when I get to the end. Come on, guys. Stop me when I get to the end. Oh, okay. All right. Okay. Let's do one more. This last one, it's y equals -0.5 times 1/4 to the x to the power of x. So here's 1/4 to the x. All I need you to do is multiply this column by -0.5. The second column, the first y value. So what's this one? -32. Before I get too far into it, any ideas what's going to happen with this function relative to the parent function that we kind of have here? Any ideas? We are multiplying this function by -0.5. It is going to do that with the 0.5. It will compress it. There's something else that's about this too. But yes, that is one of the things that happens. So there's two things that happen. All right, well, I'm not going to answer that for you, but we're going to keep graphing and maybe we'll figure it out. I think you two are on the same, describing the same thing in a different way. What's 16 times -0.5? -8. 4 times -0.5. -2. -0.5, right? What's 0.25 times -0.5? I know that one. -0.125, right? I am taking 1 times -0.5. Okay. Now, 0.0625, is that -0.03125? How about this one? -0.5 times 0.0156. 78? 0.0078? Okay. -0.5 times 0.0039. 195? Okay. They're getting small. I'm not going to go any further, I don't think. We're getting to the point that they're converging to something, aren't they? Let's graph. I can't get that one on. And I wish I'd have made this a little further down on the y-axis, but I didn't, so I'm not going to get that one. That's a reasonable one to graph. Let's graph 1, -2. Sorry, -1, -2 is right here. Right? 0, -0.5 is right there. 1, -0.125. 2, -0.03. It's getting up and up and closer. So it's kind of coming down here and curving this way. Now notice I would have if I could have, I would have graphed -3, -32, way down this way. And then if my table was bigger, I'd go even further down. All right. So I asked, what is the other? You guys are right. It is compressed. What else, though? Is this going like the other ones went? It's flipped. What flips it? The negative flips it. All righty, guys? Negative flips it. All right, so we got that plotted, but we don't have the domain and the range here yet. What do you think, Trey? Just say it. Yes. Yep. Yes. Right. Your instincts were good. Now, range is a little trickier. How low will this go? Negative infinity. How high is it going to go? To 0. Good job. All right. So that one's completely different than the first two, anyway. All right. That's a negative infinity, by the way. Okay. And I'm going to